So, di pa natin na-solve yung problem 4. So, this is problem 4. Yan. Now, personally, if I encounter beams na medyo mahirap yung figures, saka maraming loadings, yung ginagamit ko is virtual work method. Virtual work method. Now, only a few can appreciate this method. But, if you can master this method, magiging madali yung mga mahirap na figures. So here, we have an internal hinge. And then, let's first check the determinacy. Diba, we have R equals 3N. Now, for the total reactions, we have AY. We also have AX. And then here we have two reactions, CY and CX. And for the propped end, we have, for the roller support, we have, let's say, EY. So, our total reactions is 1, 2, 3, 4, 5. Tama ba? 1, 2, meron pa pala tayong moment reaction, which is MA. So, our total reactions is 6. 1, 2, 3, 4, 5, 6. Therefore, we have 6 equals 3 times the number of members. We have 2 members. This is 1. And then since we have an internal hinge, then this is split into 2 members. So, 1 and 2. And so, 6 equals 6. This beam is determinate. Now, in the analysis of beams with internal hinges, we have to first consider the equilibrium of the statically determinate part. Now, notice that if I'm going to first consider the left side, then this is essentially a prop beam kasi we have a reaction of CY. So therefore, I have to consider the right side first so that this becomes essentially a simply supported beam. So first, we have, let's cut this member right here. So this is now EY. EY, and then we have a moment load of 340 kNm, and then at point D we have 180 kN. And then we have here CY. And also CX. But CX is just going to be 0 because we don't have horizontal forces. Now, for a while, so we can take moments about C to solve EY. So I have minus EY times this span is 4 meters, this is also 4. So EY times 8 plus 180 multiplied by 4, and then minus 340. 340. And so solving EY, I get minus 8x plus 180 times 4 minus 340 equals 0. So this is 47.5. And then that's Kn. And then summing of forces vertical, I have Cy plus EY, which is 47.5, and then minus 180 for this load equals 0. So solving Cy, I have 132.5 Kn. Yan. So 132.5, and then EY is 47.5. Yan. And so, considering the left side, then this internal force must be opposite na. Since this is acting upward for the right segment, then it must act downward for the left segment. Now, for the left segment, redraw natin. Yung CY will already act downward. Yan. So, this is 132.5. Yan. And then we have 335 applied at the center. So, 335 Kn. And then this is 4 meters. This is also 4 meters. And then we have 3 reactions. We have MA, AY, and also AX, but AX is still 0. Yan. Now we can solve the reactions. We can sum up moments about A to get MA. So we have MA, that's a counterclockwise movement, and then plus 335 times 4. By the way, this is minus MA, plus 335 times 4, and then plus 132.5 multiplied by 8. So setting that to 0, MA becomes 335 times 4 plus 132.5 times 8. So we have 2,400. 2,400 Knm. And then this is acting counterclockwise because that's our assumption. Now, summing of forces vertical, AY is gonna be 335 plus 132.5. So this is 467.5. Yan. Now, these are the reactions for my real system. So, real system. I have to also solve the reactions for my virtual system. Now, we want the deflection at D. Therefore, we have to apply a unit load at this point, and then I'm just gonna assume that it will act downward. Let's just redraw the beam. Copy na lang natin to. Yan. this is now my virtual system. Virtual system. And then I'm just gonna change 180 into 1. And then I'm gonna remove the reloads. So remove natin yan. And also this. Yan. And then we're gonna solve the reactions. Now dati, yung technique ko, if I will use virtual work, di ko na ito-draw yung virtual system. Iisipin ko na lang na I have one right here, and then I will just solve the reaction simultaneously. But if I will do that kasi, maybe it will be confusing for you. So that's why we are just separating the two. Pero depende na yan sa'yo. So here we have 1, and then no need to solve talaga yung reactions dito sa virtual system because it's easy to solve since we only have a unit load. Therefore, my reaction at EY, since this is, diba, andyan yan sa midspan. So this is essentially 0.5 and this is 0.5. Half ng 1. And then automatic, lalagyan ko to ng 0.5. So my AY is gonna be 0.5 and then MA will be 0.5 multiplied by 8 meters. Yan yung technique dyan. So this is 0.5 times 8, this gives us 4 kNm, or just right 4, since this is just a virtual system. So diba, although this is although we have an internal hinge, when you are in the virtual system, madali lang talagang isolve yung reactions. So that's why I prefer this method. Now on to the next part. Diba, let's check how many segments we have. So we have AB, BC, CD, and DE. So 1, 2, 3, 4. We have 4 segments, and therefore we have to form 4 moment equations. But yung maganda kasi sa virtual work is yung calculators natin capable mag-solve ng definite integrals. So here I have the members. So we have AB, BC. Ito na lang. I will teach you the better technique. Kung meron kang dalawang segments and then merong internal hinge, dapat yung dalawang segments mo are going toward each other. So if I have AB, then my other member must be CB, so that nung tawag dito, so that my reaction, my moment equation will only include a few loads. Yan yung maganda. Pero, ano pala? Total system na pala. Sorry. So, for the total system, copy ko na lang to. Yan. So AY was ulit yan. AY is this is from the left. 467.5 kn, and then exclude mo na yung cy. Kasi di ba internal hinge yan. Walang external reaction dyan. Only internal reactions. So, remove mo na lang. And then, EY is, what is EY? 47.5. Yan na lang yung isusulat mo. 47.5. Yan. And so for the virtual system, we have yung reaction dito is 0.5 kN, or just use 0.5. And then what was AY? AY is also 0.5. So this is 0.5, and then we have a moment reaction of 4. This is 4. Now dapat magkatugma yung segments. And then we have an internal hinge at C. And then we have D. So this is 4M, 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 and also 4M. And then our unit load is applied at D. And then since we assume the deflection to be downward, then our load here is also downward. So this is change natin yung thickness. This is 1. Yan. And so I have members AB, BC, and then I will just use DC and ED. Now, D comes first and E comes first for the two, so that I will treat D as my origin for this segment, and then I will treat E as my origin for this segment. Magmamatter kasi yan. It will simplify the solutions. So for AB, we have our limits. Ideally, the limits will be from 0 up to the distance of the segment. So AB has a length of 4, so I have 0 to 4, and then BC is also 0 to 4, and then CD is still 0 to 4, and also this one. So all of these are from 0 to 4. Now move ko na lang to. Now let's move on to the moment equation. This is for the real system. Now, pwede mo nang hindi yan lagyan ng cuts. Just try to imagine that you are cutting the segment at the end. Let's say for AB, you are cutting it just right before B, and then for ED, you are cutting it just right before D. So for AB, I have 467.5. Multiply ko yan by X. Now, para sa mga hindi pa sanay sa virtual work, lalagyan ko na lang. This is my cut, and then my origin is from the left. Kasi yung starting letter ko kasi is A. That's why it's from A going to the cut. So taking moments about the cut, we have 467 times X, and then we have minus MA. Now what was MA? It was 2,400 kNm. Yan. So this is minus 2,400. Now, how about for segment BC? for segment BC, magbabago na yung cut ko. Now, since my ending point is C, then I will have to cut just right before that point. So, let's make a cut right here, and then this is now my X. So, we're just gonna consider the section to the left. So, this is X. And so, I have... by the way, ito pala yung dapat mong tandaan. Mali yung label ko. Check mo yung limits. Yung limits ng BC is from 0 to 4. So, essentially, it starts from directly at point B going to C. So, our X is actually defined by this distance. This is X. So, therefore, I have, again, in virtual work, hindi yan by segment talaga. Kasi, you have to include all the loads. If, for example, you're considering loads to the left, then you also have to include the 2. Itong reaction sa A. Although, hindi yan kasali sa segment BC, nasa left side kasi yan ang cut. Dapat mo yang i-include. So, I have here 467.5. Now, what is the moment going to this cut? I hope you would agree that that moment arm will be, this is, diba, 4 meters. Yan. So, 4 meters plus X, yan yung moment arm ng AY. So, 4 plus X. And then, I still have minus 2,400 due to the moment reaction. And then, I also have minus 335, this one, multiplied by X. Yan. So, I will try to move this. Dito na lang. Now, for DC, our segment starts from this point. So, I will just consider, let's make this cut just right before C because this is our end point. And then I will consider loads to the right. So that I will only include 180 and 340 in my equations. As well as EY pala. So since we have from D to C, then my X will start from D. So, we have this as our X. Yan. And then we have 180 multiplied by X. That's gonna cause a clockwise rotation. But, dito ka dapat careful. If you will take moments from the right, or for example, yung right side ng segment, yung origin mo, then the conventions will change. Conventions will change. Yung clockwise movements magiging minus. Yung counterclockwise magiging positive. And then upward loads become negative. And then downward loads become positive. This is because of the positive effect of the beam considering positive bending. Now, since 180 causes a clockwise rotation but we are taking moments from the right, then we're gonna use minus 180 multiplied by X. And then we have this is acting counterclockwise, so this is positive plus 340. And then this load EY, this causes a counterclockwise rotation about the cut. So we have minus, still plus because again the conventions will change. So 47.5 multiplied by 4 plus x. Again, this distance is already 4. So 4 plus x, that's the moment arm of EY. And then for ED, let's just consider this segment. So this is now my cut just right before point D. Again, you can still consider loads from the left, but it will be more tedious. So this is now x. Again, the origin is defined by the first letter. We have ED, so we start from E. So I have minus 100, minus 47.5. I mean plus pala. Sorry. So 47.5 multiplied by x. This load causes a counterclockwise rotation, so opposite convention, magiging positive. And then this load is counterclockwise, so magiging positive din. Plus 340. And so we are already done with the moment equations, considering the real system. Yan. And then we also have MV. This is the moments considering the virtual system. Now, kung ano yung segments dito, saka yung origins, it must be consistent dito sa virtual system. So again, this is the real system, this is the virtual system. So here, I have, copy ko na lang yan. The same lang naman din yung moments. But I will have to change the reaction. 467 becomes 0.5 minus 2,400 becomes 4. So I have here 0.5x minus 4. Kaya madali na lang yung virtual system, yung moments niya. Kasi pwede mo siyang i-relate dito sa real system. And then for segment BC, I have 0.5 and then times 4 plus x. 4 plus x. And then since I don't have any loading right here, then I'm just gonna include this moment reaction. So, still minus 4. Yan. Only these. Because walang concentrated load at B for the virtual system. And then for segment DC, we have the unit load right there. So I have minus 1 multiplied by x, and then plus the reaction here, which is 0.5. It's similar to this. So my moment arm is 4 plus x. Again, this load going to this cut, that's 4 plus x. And then x is still measured from point D. Yan. And then finally, for the last segment, I have 0.5 multiplied by x. And it's going to cause a counterclockwise rotation. So this becomes positive. 0.5x. Again, this is my origin. This is my cut. And then this is x. So I'm now gonna pair these moments. So by integration, I have integral from 0 to 4. These are our limits. And then I'm just gonna copy this. Now, no need mo na tong isulat sa paper mo. Diretso na lang sa calculator. But I will just demonstrate this again to those new to the virtual work method. Yan. Dapat naka-parenthesis yung m and then multiply the whole expression of mv. So, we have here 0 to 4 and then 467x minus 2,400 times 0.5x minus 4. Yan. So this gives us 56512 divided by 3. Now, check ko lang muna. 467. By the way, meron tong 0.5. 0.5, sorry. So this also has 0.5. Medyo typo lang. So 467.5. Yan. We have 56480 divided by 3. Now, isostore ko na lang yan sa A. So, shift store A. Yan. And then for the second segment, I have 0 to 4 and then 467.5 times 4 plus x minus 24 minus 335x. This is m. And then multiplying this by mv, we have 0.5 4 plus x minus 4. Type natin 467.5 times 4 plus x minus 24 minus 335x multiplied by 0.5 times 4 plus x minus 4. Yan. So press equals, we have 4240 over 3. And then I will store this into B. So shift store B. Yan. And then for the next one, I have still 0 to 4. And then m is minus 180x plus 340 plus 47.5 times 4 plus x. This is to be multiplied by negative x, this expression, plus 0.5 times 4 plus x. Yan. So minus 180x plus 340 plus 47.5 4 plus x multiply by negative x plus 0.5 times 4 plus x. So I have still 4240 divided by 3. Yan. And then finally, for the last segment, I have 0 to 4 and then 47.5x plus 340 multiplied by 0.5x. So this gives me, modify na lang natin, thus 340. Yan. And then times 0.5x. Yan. So we have 5,600 divided by 3. So I will store this at D. So shift store D. By the way, di ko na-store yung sa C, 4240 over 3. Shift store C. Yan. So A, B, C, saka D. Now, diba, yung deflection is summation of the integral of mmv dx, and then we have 1 over EI. Now, we are given 1 over EI, and then the summation of all of these m times mv, it will be A plus B plus C plus D. Therefore, my deflection at D is gonna be A plus B plus C plus D divided by EI. Now, what is E? E is 200 GPa. So we're gonna use 200 GPa, convert this to MPa to make the units consistent, and then we have 2,500 times 10 to the 6 mm to the 4th. So 25 times 10 to the 6. Now, A plus B plus C plus D has an expression of Kn m cubed, because we are talking about deflection. Now, to remember this, diba, the unit of movement is Knm. Ito yung movement, diba, integrate ka, you will get the slope equation. But you're integrating essentially x. So yung m magiging m squared na yan. And then for the deflection, integrate once more, this now becomes Kn m cubed. Yan na lang yung tandaan mo. Now, here, since this is Kn m cubed, we have to multiply this by 1,000 to the 4th to convert this into newtons and to convert this into mm cubed, so that all of our units will now be consistent. So we have A plus B plus C plus D times 1,000 to the 4th over 200 times 10 to the 3 times 25 times 10 to the 6, we get 47.04 mm. And then this is YD. Yan. Now, try to solve this using another method. Try doon natin. Wait lang. 0.5. Integral from 0 to 4 daw. 0 to 4. And then minus 0.5 x from the right, so clockwise becomes negative, times minus 132.5 multiplied by x. Okay, there's actually another way to solve 4 to 40 over 3. Now, this is a shorter method. If you'll try to look at the equation, we only have 2 components. So, sir, paano yan? You can consider the segments split into 2. So, if this is your cut, yan yung cut mo, then the only moment that will be induced at this point will be 132.5 multiplied by, let's say this is our origin, we have x, and then dito rin. So this is also x. Now, input mo na lang, 0.5x is going to be the moment caused by this load from the right. But since it causes a clockwise rotation, then we have to use minus, because from the right, the convention will change. And then for the other one, we have minus 132.5, which comes from this load, and then multiplied by x, and then still minus because this is a clockwise rotation. So you will still get 4240 divided by 3. Now let's try this for the other segment. For segment CD. So for segment CD, it will just be the same. Now this will be the cut also here. And so CY is gonna cause a clockwise rotation, but since this is from the left, then we have to use plus also for this part. So 0.5x and then 132.5x, we have 4240 over 3. So this is much simpler compared to this. So you have the option to divide this into 2.